So let's convert our example here over to use an interface instead of inheritance, and we will make it so that we can actually do polymorphism with interfaces instead of inheritance. And then we will actually be able to use composition and interfaces together to avoid inheritance altogether and basically duplicate the same functionality of inheritance without all the drawbacks. So let's take this one step at a time, and the first thing that we are going to do here is we are going to change our pointer so that it is no longer inherited from machine. Instead, let's create an interface, call it iMachine, and what we will do here is we will take out this extends machine and we'll put implement iMachine. And this implements keyword is how you implement an interface. Just like extend works to inherit from a class, implements is used with an interface. So I will go ahead and let Eclipse create this interface for me. This is one of the nice things that you can do in Eclipse, because it's automatically going to be able to create this because it realized that I was trying to refer to something that didn't exist. So I'm going to click finish here, and so it's created my iMachine interface. And on my iMachine interface, let's go ahead and declare some methods that are going to exist. Now remember, you are not going to be able to declare data, you are not going to be able to declare the actual implementation of method, but just what this interface looks like. So let's create our methods. Let's create our turn on and turn off method, because any machine should have turn on and turn off. Now we had implemented this in machine, but for now we are just going to in your machine, and we are not going to utilize machine at all. We are going to just make it so our printer is implementing this interface instead. And so now you can see we have got a whole host of problems here because we don't have the ability to call this isOn or to use isOn or to basically use this base class, since we are not using the base class anymore. In fact, what we need to do is we need to implement these methods ourselves, because we are not getting the implementation from anywhere. When we inherited from machine was providing us with these turn on and turn off methods. So I will use Eclipse here again, and you can see I can just click this to add an implemented methods, and when I do that, what is done here is it's created a turn off method and a turn on method. In fact, we already have a turn on method, so it didn't try and recreate that because that is part of the interface, but it did create a turn off method because we need to have a turn off method. So I'm actually going to move this isOn back into our class for now so that we can implement this interface properly. So I'm going to create a private variable, Boolean, call it isOn, and I'm going to set it in our constructor here just like we had done before. And we are going to say that this dot isOn equal isOn. And now when we want to call turn on, we are going to just implement this ourselves. We are going to say isOn dot true. And then for turn off, we are just going to set isOn dot false equal false. So now you can see we have no dependency on the machine class. We created this iMachine interface, and we are implementing this interface by having an overriding method for turn on and one for turn off. Now what this is going to allow us to do is to basically, instead of referring to our object as a machine, we can basically use this iMachine interface here. And we can set our printer equal this iMachine interface, and we have to import this type, of course, to be able to use iMachine. So now we have an interface that is referring to our printer, and then we can call turn on that interface. So we can call any methods that exists on this interface. We don't have to know what the implementation is. Printer implements it. And so let's go and run this and see what happens here. So you can see it just has the warming up print engine because it's calling the turn on method in printer when we use that interface. Now let's take this one more step further, and let's go ahead and make it so that we are going to use composition in order to avoid having to repeat this logic. Because we had this logic for the isOn in machine, and the problem with using an interface, a lot of people complain, is, well, I don't want to repeat this code and manage this is on, this logic in every single class. If we created another printer, another type of machine, we would have to implement the machine interface and re-implement turn on and turn off. So we are going to use machine as kind of a base, but we are not going to inherit from it. And the way we are going to do that is we are going to have machine implement the iMachine interface. And then we are going to have our printer class have an instance of a machine. So just like we did with paper tray, we are going to create a machine variable called machine. And we are just going to leave this machine here, and then in our constructor we are going to construct our machine. So I'm actually going to check this is on variable out again, and instead what we are going to do here is we are going to say that machine dot or equal new machine, and we are going to pass the is on here. So the machine is going to manage this, is going to have that logic. We are going to check this logic for handling the is on out of our actual class, and then this turn on method, we still have to implement a turn on and a turn off method. But all we have to do here is we can just say machine.turn on. So we are going to delegate, this is called delegation, because we are going to implement this interface by delegating it to our internal machine class. So for turn on we just call machine.turn-on. For turn off we will just call machine.turn-off. And then this has actually helped us to figure out part of the interface that was missing, that we didn't even think about here, just that this is on. We need this machine interface to provide a way for us to tell if the machine is on, not just to set the state of being on or off. So I'm going to go ahead and implement a method here that would allow us to check is on. So I'm going to change this instead of a variable to a method call. And we are going to create this method. But we need to create this in our interface first, and then we want to create it in the machine, because we don't want to implement this in our actual printer. So let's go into our interface here, and let's create a method that returns the boolean called is on. And now you can see both machine and printer have an error here because they need to implement this method. So I'm going to click add and implement methods, and for machine it's going to have an is on, and the way that we implement is on is to return the value of our is on variable. Then in printer, the way that we are going to implement is on is we are just going to return the value of our machines is on. We are just going to delegate our call. So we are going to return machine.isOn. So now you can see that the same thing here, when we want to check our is on, we are just going to do machine.isOn. So now you can see we are actually not inheriting from machine, but we are able to use machine through composition. So we have the same polymorphic behavior. If we go to our main class here and run this, we are now using iMachine, and our iMachine can either hold a printer or machine, and it's going to call the turn on method. And so if I call this turn on method here, you can see it's calling the code inside machine. And if we decided that we didn't want a printer to use machine's method, or we wanted to use machine's method but we wanted to do something else as well, we can just do system.out.println, and for example we can say warming up printer. Now if we run this, you can see that it's calling our code, which is delegating to machine.